Hi friends, welcome to Fresh Library YouTube channel. Today in this session we are going to discuss about base conversions. Base conversions. Before proceeding into today's session, let's recap our previous sessions, what we have discussed in the last class. Okay, so till now we have covered all these topics. What is Python? Who and when invented? By Python? Flavors of Python installation, ideally and PyCharm usage, writing small programs, and limitations, rules. Okay. Now we are discussing about data types in Python. This is the only topic. This is the only big topic in our sessions. Okay. Till now we have discussed about data types. That too about integer data types. That too about integer data types. I'm going to show that. So here Python, basically Python have two types of data types. One is fundamental, the second one is collection. Fundamental data types allows you to give only single values. Collection data type means in the name itself it says that collection means you can give multiple types of inputs. Okay. And integer means numbers. Example of this is a equal to 10, type of a. If you type this one, then it will automatically print the which type of number we have, which type of data we have stored in that kind of variable. Okay. And these are the four types of data types: decimal, binary, octal, hexadecimal. So decimal is an default number system. Okay, default number system means we no need to specify uh, what is the base of the decimal number. And if you can give directly decimal numbers as inputs to the Python, we don't need to specify like binary, octal. For binary and octal we need to specify which type of data we are going to give, like 0b represents binary, O represents octal. For hexadecimal, we need to specify with X, like this. Either small x or capital X. For octal and base also we can give small b or small o or capital B. Okay. Till now we have discussed about all this. Now we are going to discuss about base conversions. Base conversions. So what are the types of base conversions we have? We have, or we can convert to binary to decimal, decimal to hexadecimal to binary, like that. Base conversion will have. In this, we are going to explore in this particular topic. So first one is binary. But we no need to convert the decimal numbers, because decimal number system is the, or decimal data type is the default data type in Python. Default data type in Python. So what we are going to convert binary and octal. Octal means OCT. Next, hexa, HEX, hexadecimal. Hex means hexadecimal. Okay. Now, how we can convert these numbers? How we can convert these numbers? Let's open IDLE. Yeah. First, I want to convert binary numbers like how we can convert. Let's give some input binary of 1 2 3. So here 1 2 3, actually 1 2 3 are the data types in octal, right? Because it will accept from 0 to 7, 0 to 7. And here we have specified 1 2 3. Let's take another numbers also. Bin of binary of some 7 4 5. Okay. So here it was converted directly. We don't need to specify. We need to write such much program. Just we can enter the data type which we want to convert. Then we have to give the number which are going to convert. Then it will automatically convert that number. So here 0. So 0 is the base number, and B means binary. Okay. Here we are converting binary numbers. We are converting another data types into binary numbers, right? That's why it is showing 0b. In the same way, if you want to convert the octal number OCT of 1010, so it was converted to octal number. 1010 is the binary value. 1010 is a binary value because it will accept only zeros and ones. Now it was converted into octal number. Okay, now it was converted into octal number. Next, if you want to convert to hexadecimal, hex of some 20. Okay, so it was converted. 20 means 0, x means hexadecimal. Normal number, it was converted into hexadecimal. Okay, 1 4. This is the hexadecimal format. Okay, this is about base conversions in uh, Python data types. Okay, so here how we converted first binary number. For these are the examples. Okay, and now I am going to specify here examples. Otherwise, we can take what we convert. Without wasting time, we can directly take these. Hash. Next, for binary conversion, we have taken like that. And for next octal. And then last one, hexadecimal. Okay, this is how the base conversions will be. Okay, so we have completed the integer data types. Okay, integer data types: decimal, binary, octal, hexadecimal, and conversions from one to another, binary to octal, octal to hexadecimal, like that. Okay, now we are entering into another topic called float data type. Float data type. Next, so in this uh, we can use float data type to represent floating numbers. We can use float data type to represent floating point values. Okay, examples. Let's have some practical idea about this. Okay, what are the float data types? Float means point 1, 0.1, 1.2, 2.3, like that values we can call it as float data types. Okay, for suppose float f equal to, just wait for a minute, because of some unused words in keyboard that we were showing some error. Now I have to open another one. F equal to 1.2, sorry, 1.2. So, and some v equal to 2.0. These are point values are considered in floating data types. Float data types. Okay. Now, if you want to know about whether which data type we have given, just type here type of f. So float. Okay, it is showing that float, and type of v. Type of v also float only, because we have given 0.0 by 0.0. Okay. Next, we can write the definition here for that one, and then what examples we have taken we can paste here to understand in a better way. So we can use float data type to represent floating point values. Decimal, example in brackets we can specify decimal values. Decimal values. Example, what examples we have taken while doing practical? Here These are the examples. Type of f, float. The same way, type of v also float. Next, so we can also represent the floating values in exponential format. We can also represent the floating point values by using exponential form or scientific notation. We can also call that exponential forms as scientific notations. Okay. So what is that exponential? What is that scientific notation? We can see. We will see. Okay. Now I am taking one input here that is equal to floating. Just wait. I'm opening the fresh one. Okay. Floating value f equal to 1.234. 1.234. Sorry. 1.2 E3. Okay. Next, what will be the f value? See, f value is 1200. Here we had given one exponential form. Exponential means e. Exponential forms are represented as e. Okay, and is it here we had given small e. Let's try with capital E, whether it will take or not. 1.2 capital E 3. Same value I had given, but with capital E. Whether it will take or not, it will take. So it is not given any errors, syntax error or any other errors. So that means that it is accepting the capital E values also. Capital E values also. If you want to know the value of f, then you can press F and then press enter. Then it will show the same value. For small e, it is showing the same value, and for capital E also, it is showing the same value. So we can understand that we can use both small e and capital E. So here I'm writing the same thing here. We can also represent floating point values by using exponential form or scientific form. We can also call exponential forms as scientific form or scientific notation, we can call. scientific notation. Examples of these are f equal to 1.2 E3. What value it was given for 1.23 2E3? F hash 1200 dot 0. It is only it was shown, right? 1200.0. And here a small note for this. Instead of small e, we can use capital E. Capital E. So okay, capital will E values also it is accepted. That's why it has not shown any error. So here we have specified capital E, but it is also accepted. Examples: f equal to 1.2 1.2 E, so capital E to E3. The main advantage. So why we are going for exponential? We can represent in normal floating values, right? But why we are going for exponential or scientific notation? Because see here, f equal to 1.2 E3. It shows that it is a normal number, like it is specifying a small numbers. Uh, but if, instead of so here we can see 1200.0. So it is showing that it is a large number. It is showing that it is a large number. Instead of representing these large numbers directly, we can use exponential forms. We can use exponential forms. That is the main advantage of exponential forms. That is the main advantage of exponential forms. In order to represent a large number of values in a small number of values, then we will go for exponential or scientific notation. That is the main advantage of exponential. Main advantage of exponential. Exponential form is we can represent big values in less memory. It will also occupies less memory, right? So instead of storing this value, if you use this one, it will occupy very less memory. That is the main advantage of exponential form. That is the main advantage of exponential form. Next, So if you here we have a some small doubt that if you give uh, any other formats like hexadecimal or binary numbers, whether it will take is it take or it will give error, it will throw an error. Here is here we have that kind of doubt. So in order to clear that, we have to do that in a practical way. So here I am going to give one binary number 0 b 0 b 1010 dot 0 1. Why we are given 0 1? Because we are talking about floating values. Okay, floating values. Floating means dot 0 or dot 1 or any other numbers must be there. So that's why we are going giving this kind of values. So whether it will accept or not, let's check. It will not accept these kind of numbers. It will give syntax errors. It will give syntax error. Why? Because the Python will only takes the decimal values, because the decimal form is the default form of the Python. Okay, default data type in the Python. Let's give some other input. F equal to um, 0. Let's give some hexadecimal number like x 0 x 1 2 dot a b c d or a b d c. Anything is okay. So whether it will take or not, it will not accept. It won't accept. It won't accept. Okay, because it will only take decimal values. Why? Because decimal value is the default value in the default data type in the Python. Okay, this is all about floating numbers. This is all about floating numbers. Do you have any doubts regarding this? Please comment below. I will try to sort it out. I will try to sort it out. Okay. Yeah. Thanks for liking and subscribing our Fresh Libraries YouTube channel. Yeah. Thank you.